2.5, properties of functions. Properties of functions. You can have increasing functions, decreasing functions. Functions can both increase and decrease in the same function. An increasing and decreasing function. The definition, we're going to let f be a function. X sub 1 and x sub 2 are any two numbers in the open interval from a to b contained in the domain of f. The symbols a and b will represent real numbers that are negative infinity to positive infinity. F is an increasing function on the interval a to b if x sub 1 is less than x sub 2 implies that f of x sub 1 is less than f of x sub 2. And really the subscript should be inside f of x sub 1, it really should be there. And 2, 1, and 2, inside, not outside. 1 and 2, and not outside. Okay? So that's an increasing function. So here's what I'm saying. It's increasing if an x and y axis, I have some a here, I have some b here. This is f of a, this is f of b. If your first one, x sub 1, is less than x sub 2, it implies that f of x sub 1, or f of a, is less than f of x sub 2. And it is. It's below it. It's less than. So you could do x sub 1 here and x sub 2 here. So then this right here would be f of x sub 1. This right here would be f of x sub 2. X sub 1 is less than x sub 2. F of x sub 1 is less than f of x sub 2. That is an increasing function. F is called a decreasing function if for x sub 1 is less than x sub 2 implies f of x sub 1 is greater than f of x sub 2. So again, I have an x-axis and a y-axis. And I have some function here. There's my decreasing function going down. I have some x sub 1 here. I have some x sub 2 here. This right here is f of x sub 1. This right here is f of x sub 2. Notice x sub 1 less than x sub 2. Here, x sub 2 is less than f of x sub 1. F of x sub 1 is greater than f of x sub 2. So here's a decreasing function. Or we could have a constant function. Not increasing, not decreasing. There's my x sub 1. There's my x sub 2. My f of x sub 1 and f of x sub 2 are equal. And that's a constant function. Okay? You could have functions that, the reason I have this up is I want to show you, you could have functions that are increasing in parts and decreasing in parts. For example, 1, 2, 3, 4, 5, I'll do here. Maybe I'll do this. I have some graph here. And then I'm going to go here. And then I'm going to go down here. And then I'm going to increase it again. Okay. So there's my function. You can look at this and say, okay, you can see that it's increasing there. And it's increasing there. But if I ask you to write where it's increasing, you could write that it's increasing from 1, 2, 3, 4, 5, actually, negative 5 to negative 2. Because x is negative 5 here, x is negative 2 here. It is also increasing, so union 1, 2, 3, 4, 4 to 6. So that's where that's increasing. It's decreasing just right there. So it's decreasing from 2 to 4. Okay? And it's constant right here. So from -2 to 2. So constant. It's a constant from -2 to 2. Relative maximums, relative minimums. Sometimes they're also called local maximums and local minimums. If A is in the domain of the function f, we say the value f of A is a relative minimum of f if there is an interval x sub 1 to x sub 2 containing A such that f of A is less than or equal to f of x for every x in the interval from x sub 1 to x sub 2. So, let me show you what I'm talking about. I have something right, I have an x and a y graph right there. And I have some graph that might look like, I don't know, how about this? I don't know, there's my graph. Okay? So that's what the graph looks like. Relative minimum. What they're saying is if I go between some interval, x sub 1, here's x sub 1, here's x sub 2. Okay? This right here, local minimum, that's my f of A that they're talking about. So this point, that lowest point, is smaller than all these f of x's. The smallest point. So that's a local minimum, or relative minimum. A relative maximum on an interval from x sub 1 to x sub 2, it contains an A such that f of A is greater than or equal to f of x. So if I have an interval, I don't know, from here to here, that's my highest point. That's my f of A. It is higher than all these f of x's. These are lower. These are lower. That's the high point in there. Okay? So, relative minimum, relative maximum, or sometimes local minimum, local maximum, they're called. And these are also turning points of the graph. Those are turning points of the graph. Even and odd function. A function's even if for every x in the domain of f, negative x is also in the domain of f. And f of negative x is equal to f of x. And hopefully that looks a little familiar when we were talking about symmetry. This would, an even function, if you graphed it, is symmetric with respect to the y-axis. So it's symmetric with respect to the y-axis. So the right and left are mirrored images of each other. Okay? So for example, there, the absolute value of x, that's an even function. Okay? And you can algebraically see if a function is even by, if this is my function, plug in negative x, and that's really the same thing as absolute value of x. So I get back to where I started from, the original equation, and that's an even function. An odd function, x is in the domain of f, negative x is also in the domain of x, and f of negative x is equal to negative f of x. So the graph of, we should say odd functions is symmetric with respect to the origin. Okay? So I might have a graph that looks like that. That is an odd, that's an odd function. Okay? This is f of x is equal to x cubed. If I plug in negative x, I get negative x cubed, which is negative x cubed. So here I plugged in a negative and got the negative of my f of x. That's f of x, I got the negative of it. So there's an odd function. Okay? So let's test a few more. I'll give you some examples up there. Test a few more. So I'm going to plug in a negative x. I'll see if I get to the original equation. I'll see if I get to the negative of the original equation, or I'll see if I get neither, okay? So if I have f of x is equal to x to the fourth plus 3 over 2x cubed minus 3x. Instead of x, I'm going to plug in a negative x. Instead of x, I'm going to plug in a negative x. Negative x to the fourth is just x to the fourth. So I have x to the fourth plus 3 on the top. Here I have negative 2x cubed plus 3x. Okay, there's my equation that I have. I'm going to rewrite it. I'm going to factor out a negative from the bottom and just rewrite it like this. It's the same thing, just rewritten. And now I hope you can see that there's my f of x, so I have negative f of x, so this one is odd. So this is an odd one. This is showing algebraically that it's odd. Average rate of change. Let me give you an example that we can all relate to, prices of things. Let's say the cost of eggs increases from 80 cents to $1.40 over a 3-year period. Everybody should be able to find the rate of change in the price. You know that the eggs went from $1.40 or 80 to $1.40, so it went up by 60 cents over that 3-year period. So it's 60 cents per 3 years, so that would be 20 cents per year. And we could all do that. But now we're going to do rate of change, but there might be some x's in there and letters. So we have 2 points, an x and a y, or an a and an f of a. An x or y, x and a y, which is a b or a f of b. There are 2 points on the graph. The average rate of change is defined as f of b minus f of a over b minus a. And really, that's what I did. I found out the price after 3 years. This was my price at time 0, so I took the difference, $1.40 minus 80, over my time. Time 3 years to 0 years. So I divided by 3. So, and like I said, the example for the eggs, now, at time 0, you'd say it's 0.8 cents. At time 3 years from now, it's 1.4. If you plug it into that equation, it turns out the same as this. Okay? So that's rate of change. What do you notice about this? This is the y, change in y. This is your x, change in x. This is the slope. That's slope. Remember, slope. Change in y over change in x. That's my slope formula. So find the average rate of change of f of x is equal to x squared minus 2 from x is equal to 2 to x is equal to 4. So I want to find f of 4 minus f of 2 over 4 minus 2. That's what I want to do. So f of 4, if I plugged it in, 4 squared minus 2. F of 2, 2 squared minus 2. Over 4 minus 2, or 2 on the bottom. Be really careful, because if you have x's in here, you do want to definitely have that parenthesis, because you'll distribute that negative. So 4 squared is 16 minus 2 is 14. 2 squared is 4 minus 2 is 2. 14 minus 2 is 12. So the average rate of change is 6. Okay? Now I want to find the average rate of change of x squared minus 2, but this time it's going from c to c plus h. So let's plug that in. F of c now, or c plus h, sorry, because it's f of b, minus f of c, over c plus h is my b, minus c is my a. Okay? So in my f function, instead of x, I'm putting in c plus h. So I have a c plus h quantity squared. Minus 2. And here I'll just put in a c. So I have c squared minus 2. On the bottom, notice I have a c and a minus c and an h. So the c's cancel out. If you FOIL that c plus h, you will get c squared plus 2ch plus h squared. And I still got minus 2. And then I have minus c squared plus 2 all over h. This is where I said be careful, that negative. So here's what I'm going to do. Distribute the negative. Notice, positive, negative cancels out. Positive, negative cancels out. So I have 2ch plus h squared over h. I can factor out an h from the top, and then they cancel out. So then I'll have 2c plus h. And I'm done. So the average rate of change that we calculated, that is called the difference quotient. This right here is the difference quotient. Okay? And the difference quotient is f of x minus h minus f of x over h. That's the difference quotient. And we'll be using that. So find f of x plus h, f of x plus h minus f of x, and the difference quotients. For f of x is equal to 3x squared minus 2x plus 5. So f of x plus h, I'm going to plug in x plus h wherever I have an x. So I have 3, wherever I have it, right there, 3 times x plus h quantity squared minus 2 times x plus h plus 5. This right here factors into x squared plus 2xh plus h squared. That right there, you can distribute it. And I distributed the negative 2. So I took away the parentheses. So negative 2x minus 2h. Distribute the 3. So I distributed the 3. Okay? So there's f of x plus h. Now, I want f of x plus h minus f of x. So I want this minus f of x. So that's the next thing I'm going to do. This is what I have in the first part, minus my f of x. Distribute the negative. And notice, positive, negative. Positive, negative. Positive, negative. And I have 6xh plus 3h squared minus 2h. Last step is divide this by h. So this right here, divided by h. Factor out an h, and you have 6x plus 3h minus 2. And you're done. Okay? The homework for this section, section 2.5, will be changed a little bit, not a lot. I will tell you in class, but it will be, you can look on Schoology too. It's 3, 5, 7 through 17 odd, then 21 through 47 odd, 55 through 65 odd, 77, 81, 83, 87, 99, I only want you to do A and B, and 101.